Hello, good morning to all. I am Khaja Asifullah, lecturer in chemistry from Government Degree College, Falaknuma, Hyderabad. Today, I present a video lesson on thermodynamics from chemistry. It's part 2 because in last lesson or part 1, we discussed the basics. The same thing we will continue in this second lesson or part 2. Today, we will discuss first about the reversible and irreversible processes. First, what is a reversible process? When a thermodynamic process occurs in such a way that properties of the system at any instant remain practically uniform, the process is called reversible. And what are the properties? Properties like temperature, pressure, etc. The reversible process can be conceived to proceed very slowly through a succession of infinitesimally small steps, and its direction can be reversed at any point by making a small change in a variable like temperature or pressure, etc. So the reversible reaction has to be carried in very small steps by changing the temperature or pressure of the system, and the direction can be reversed as we like, in forward direction or in backward direction. A reversible process is that process which is carried out in infinitesimally slow steps to that all changes occurring in the direct process can be exactly reversed, and the system remains almost in a state of equilibrium at all times. So, in a reversible process, equilibrium is attained by changing as the temperature or pressure or both, we can attain equilibrium. What is the equilibrium state? The rate of forward and backward reactions will be same. At equilibrium, both rate of reaction in forward direction and rate of reaction in backward direction will be same. The meaning is that equilibrium state is that a state in which few reactants, if we take a chemical process, few reactants will be converted into products. At the same time, few products may be converting back into the reactants. So the equilibrium state is a dynamic one. A reversible process may also be defined as that which is carried out in stages, and the driving force at every stage is only infinitesimally small, greater than the opposing force, and which can be reversed by increasing opposing force by an infinitesimal amount. So if we change the force, then it will move in a certain direction. Again, it will attain the equilibrium. Here is a schematic diagram of a system which may be called as a reversible system or reversible process. It is a system in which a gas is enclosed in a cylinder with a movable piston. This is the volume of gas, whereas the total volume of cylinder is this much. This is the total volume of the cylinder. This is the volume of gas which is enclosed in the cylinder, and this is the movable piston. Now, the gas either can expand in this direction if the piston moves up, or it can contract or compressed if the piston moves down. But to move the piston up or down, we need certain force to be applied on the piston. Our force per area is also called as pressure. So when we apply pressure or we keep certain force on this, some force means some pressure will be applied on the piston. As a result, the piston will move down. If we remove certain force from the piston, the pressure will decrease and the piston will move up. In this way, the volume of system will change, or the volume of gas will change. If the volume increases, it is called expansion, and if it decreases, it is called compression. So in both ways, the pressure plays the major role here. So if we keep some weight here, for example, instead of keeping 1 kg, 2 kg weight, we can keep grains here, so that if we remove 2, 3 grains, the change in pressure will be very, very, very small, or it is called infinitesimally small. Similarly, if we add few grains, very small pressure will be increased on the gas. Now, there can be two types of pressure here. One, the molecules of the gas will hit or collide with the walls of container as well as the surface of piston inside the cylinder, exerting some pressure that is called pressure of the gas. And this pressure which we are applying here is called external pressure, and the pressure of gas is called internal pressure. Now we are talking about the external pressure only, means we are adding some pressure or we are removing some pressure by keeping some mass here. So instead of big bodies, we can take very small grains so that their mass or weight will be very, very less. If we add few grains, some weight or force will be increased. As a result, some pressure will increase. If we remove few grains, the pressure will be decreased. But the change in pressure will be very small, called as infinitesimally small. Now, if we think that this is the first state or initial state of the system, and the system comprised of the gas taken in a cylinder. Now, if you see the second cylinder in this figure, it is shown that few weights have been removed from this surface of the piston. Here, only one block is shown here. 3 blocks means 2 blocks are removed. So pressure applied or external pressure is decreased. And what will happen? The gas will expand and the piston will move up. Now, one more thing we have to understand here. This is the volume in the initial. This, let us call it as initial state of the system. And this is the final state of the system. From left to right, we are moving. In initial state, let this the volume V1. And in this V2, because it is second state, we can say it is V2. Now the volume of gas is increased because the external pressure is decreased. Why it is increased? Because molecules will exert pressure on this piston. As a result, it will move up. Means the gas molecules are doing some work. So gas is doing some work. We will discuss this type of work later. But here what we have to understand is whether it is a reversible system or process or not. Now, in third figure, few more blocks have been removed, means some more pressure, external pressure is decreased. As a result, the volume of gas again increases. Okay. Now, if we add again few blocks to the surface of the piston, the external pressure will increase again. It was decreased and reached minimum value. Now it is increasing. Now you can see the volume of gas is decreased. Means when we apply external pressure, the volume of gas is decreased. Again, if we add few more blocks, so that the state of system is brought to its initial state. This is the state from which we can compare this two, this first one and the last one. These are similar. So this system is brought into initial state, means the system is a reversible system. Initial to final, again final to initial. This is first figure represents the initial state or first state, and this is final state. Again we are going back to first state. It is a cyclic process. So we have reached first position or first state, hence it is a reversible process. This can also be shown in the form of graphs like this. Here pressure, volume. The above system is shown in this way also. Here, when the pressure was this much, the system had some value. It is the corresponding volume for that pressure. Now, the pressure is decreased slowly. The pressure is decreased slowly because we have to bring infinitesimally small change in pressure so that we observe infinitesimally small change in volume. Therefore, as we change or we decrease the pressure, the volume is increasing and it is reaching the maximum volume. This is the final stage. This was first state or initial state. This is the last or final state. Now, if we want to bring back the first state of the system or go back to initial state, what we had to do? We had to release, we had to increase the pressure so that the volume get decreases. Again, we reach the first point from where we have started. So it is the initial state. Therefore, this is a cyclic process. So in a cyclic process or in reversible process, when we bring infinitesimally small change, there will be change in the system. And if the conditions are reversed, what type of conditions? Conditions of temperature, pressure, etc. We can attain again the initial state. Now coming to the irreversible process. An irreversible process is a process in which is not carried out in infinitesimally small step and slow step. Instead, it is carried out in a single step and thus cannot be carried in the reverse order. So this picture shows two different types of processes. Here, this one is a reversible. If we start from first position, go to second position or initial to final. Again, if we come back to initial, it is called reversible. And irreversible is that in which we cannot come back to the initial position. For example, if we take chemical process, if we burn a substance in air, it is irreversible process. Okay, we cannot bring back the reactants, or we cannot get again the reactant from the product. Whereas if we think the natural processes, nearly all are irreversible processes. In nature, spontaneous reactions takes place. We cannot go back to the initial state, or we cannot get reactants from the product in natural processes because they are spontaneous and they occur fast. Even if it is slow, we cannot go back to the initial state. So nearly all natural processes are irreversible, or that is the real situation in the universe. Whereas reversible reactions are not real. We have to why they are not real? Because we have to control the conditions of temperature, pressure, etc. And we have to change their values so that we achieve the final state and again go back to the initial state. In this way, these reversible reactions will not take place generally in nature. These are controlled reactions which can be carried out in laboratories or in industries. And in nature, the reactions which take place are uncontrolled and spontaneous in nature. For example, if we take preparation or manufacture of ammonia in industry, that we called as a reversible reaction in which reactants nitrogen and hydrogen combine to produce ammonia. If we control the reaction conditions, that is temperature, pressure, concentration, etc., we can go back to the reactants. That means after certain times, the product formed from the reactants may convert themselves into reactants. So equilibrium will be achieved in a reversible reaction, whereas in irreversible reaction there will be no equilibrium achieved. So under controlled conditions only we can achieve equilibrium, and those will be called as reversible reactions, and this will not take place in nature. Now the differences between a reversible process and irreversible process. First one, a reversible process takes place slowly and in infinite number of infinitesimal small steps, which is not possible in practice. So in nature, it is not possible. Only in the controlled conditions of temperature, pressure, concentration, we can carry a reversible reaction or reversible process. On the other hand, an irreversible process takes place in one rapid measurable step. Thus, all processes which actually occur are irreversible. As I told you just now, if we burn anything like wood in air, we cannot get wood again, and it will be a single step process. We cannot bring back wood. Therefore, this is a natural process which is uncontrolled and spontaneous. There are many such reactions taking place in nature which are irreversible processes. Second difference, a reversible process is unreal as it assumes the presence of a frictionless and weightless piston, while an irreversible process is a real and can be performed actually. As we know, in nature, only irreversible reactions or irreversible processes takes place, and we have to control the conditions so that a reaction becomes reversible. Therefore, it is unreal. In reality, reversible processes are not possible. Again, if you go back to this figure, here we are changing the conditions of pressure. As a result, the state of the process or system is changed. We can reach the minimum or maximum volume for gas. Again, we go back to minimum, or from more pressure to less pressure, again to high pressure, like that. For a reaction to be reversible, we need a frictionless piston. Okay, therefore, it is not possible in nature. Weightless and frictionless piston we require. Third is a reversible process is in equilibrium state at all stages of the operation, while an irreversible process is in equilibrium state only at the initial and final stages. A reversible process like a chemical reaction will be in equilibrium state at all stages during the operation. Whereas in irreversible processes, the equilibrium is observed at initial state and in the final state. Next is an irreversible process can be made to go in either directions, while an irreversible process can proceed only in one direction. Just now I told you an example, burning of a substance in air is unidirectional. Why? Because we cannot get the backward reaction or we cannot get the reactants. So it is a unidirection. It will proceed in only one direction, whereas a reversible process will go into both the direction, forward direction as well as in backward direction. For example, if we take the example of manufacture of ammonia, in which nitrogen and hydrogen are reactants, they react to give ammonia. After some times, when equilibrium is achieved, ammonia may convert back into reactants like nitrogen and hydrogen, which is the backward direction reaction. The next difference is work done is reversible. Work done in a reversible process is greater than in the corresponding irreversible process. Always, it is true that work done in reversible process is greater. Why? Because this reversible reaction or reversible process is taking place in controlled conditions. Under controlled conditions only, a process may be reversible. So we can achieve maximum work done, or we can get maximum work done. Whereas in Irreversible processes, only once the reaction will take place and in only one direction. So we cannot control that reaction and we cannot get maximum work from that process. Now coming to work and heat. We know that work and heat are interrelated, and work and energy also, because heat is a form of energy. We need some amount of energy to do some amount of work. So what is work? Work is nothing but energy only. When a system changes from one state to another, energy is transferred to or from surrounding the system, from surrounding. That is, there is a change in energy. This energy transferred as heat or work. If we consider two different states of a process or system, then there will be change in their energy. Then where the difference of energy has gone, either it was transferred in the form of heat to the surrounding, or the system has done some work. Only two possibilities are there for that system. If we consider a system in first state or in initial state, where it will possess certain amount of energy. Then if we consider the second state, again there will be some amount of energy it will possess. If first state has more energy and second state has less energy, then there will be difference in energy. That energy either will be transformed or transferred to the surrounding by the system in the form of heat. It will lose heat. As a result, it will lose energy. Or the system will do some work if we utilize it, or in both way it can lose energy by losing some energy in the form of heat and doing some work. So it can, there are three conditions. Either it can lose energy in the form of heat totally, or it can do work, but it is not possible to extract 100% work from a system. So a system cannot be 100% efficient. So there is third possibility that it may lose some amount of energy and do some work. So the sum of those two will be equal to the energy lost by the system. Now work done may be of different types. If we observe the nature, there can be different types of work, like mechanical work, in which we do some work. The body will do some work. Electrical work, like gravitational work, etc. Now, what is a mechanical work? A mechanical work is defined as the displacement of the system with application of a force. If you consider a stone at rest at point A, if we apply some force, it will move to certain distance, or it is displaced, the displacement. So we can say some work has been done. And how can we calculate the mechanical work? If we have certain force and it is moved to a certain distance, then the product of these two is called mechanical work. Or we can formulate an equation, W is equal to F into L, where F is force and L is the distance traveled by that object. So if F is magnitude of the force applied on and L is the displacement of the point of application, then the work done is given as W is equal to F into L. For example, in this figure, this person is moving the wheel, and when wheel is moved, it will travel certain distance and it will have certain mass. So force into the distance traveled is called the work done. Similarly, this picture also depicts the same thing. This is the force 12 Newton. It is moved to 5 meters. When we multiply this, we will get the work done. We have another type of work called as electrical work. Here, what is electrical work first? We know that every current or electricity has certain EMF or voltage. That voltage multiplied by I, that is quantity of electricity or current, the product of these two is called electrical work. So W is equal to V into I. This is I, current. So electrical work is given by EMF into quantity of electricity or the voltage into quantity of electricity, that is V into I. The product of V into I is called work. For example, this is a charge. It is a positive charge. It is moved from this point to this point, means it has traveled a certain distance d, and the particular charge will have voltage I, Vi here, our initial voltage. When it travel to second point, it will have certain voltage Vf. So there is change in voltage, or it is called potential difference, delta V, and it is given by F into D by Q, where Q is the charge, D is the distance, force by which it was moved to this much distance, and Q is the charge on this charged particle. So it is Fd by Q. So moving a positive charge requires certain work to be done. Similarly, we have gravitational force. It is again a type of work, gravitational work, and it is the product of three quantities: mass into acceleration, gravity, and height. So gravitational work is the product of mass of the body, which is kept at a height h, and some acceleration due to gravity g is acting on it. So the product of these three things, mass of body, g, that is acceleration due to gravity, and height at which it is kept, the product of these three is called gravitational work. For example, here in this figure, mass is in the ground level or at the surface of the ground in the first state. Then it is kept at height h. Now it can do certain work. For example, water kept at a height or stone at a height. When it rolled back, it can do some work. So this is the height from the ground. So h into m, and we know acceleration due to gravity. So the product of these three will give you the gravitational work. This figure also depict the same thing or illustrate the same thing. Now we have one more type of pressure which is very, very important for our purpose. That is because we are dealing with thermodynamics. In thermodynamics, this type of work or this sort of work is very, very important. And this type of work is called pressure volume work. And what is pressure volume? When we take a gas, here we need gas. And gas is enclosed in a cylinder fitted with a piston. It will have certain volume V. If we apply the pressure on the gas, that is called external pressure on the gas, the volume of gas will decrease. If we remove or we decrease the pressure on the gas, that is external pressure is decreased, volume of gas will decrease. So the product of these two, P into V, is called work, or work is equal to pressure into change in volume. Why change in volume? If we add pressure or increase pressure, volume will decrease. So change in volume is important. If we remove the pressure, then change in volume again is observed. But when pressure is applied, volume decreases. When pressure is removed or decreased, an increase in volume is observed. So there will be two different types of work it can do. It is called as expansion and compression. So pressure volume work or PV work or expansion work is the most important form of work used in the study of thermodynamics. So it is very useful in thermodynamics. It is the work done when the gas expands or contracts against the external pressure, generally atmospheric pressure. Okay, this is external pressure. If it is equal to atmospheric pressure, okay, then equilibrium will be achieved. Otherwise, we have to apply the pressure to decrease the volume of the gas. Now, it is a type of mechanical work because certain distance the piston will travel when we apply pressure to it. Similarly, when we remove certain pressure, it will move up. So again, it will travel certain distance. So it is a type of mechanical work, and it is given by pressure into volume. So this type of mechanical work where change in volume is important, it is given by the product of pressure and volume, or change in volume. Now this again illustrates the same thing. This is the cylinder inside which a movable piston is fitted, and this piston can be pushed or pulled back. When we push it in, means we are applying some pressure. The volume of gas V1, which is the volume of system in initial state, will decrease. Why? Because we are applying pressure and the piston is moving downwards and it is traveling certain distance. This much distance it is traveling d. So the volume of gas decreases. So V2 is less than V1 here, or the volume of gas in second state or final state is less than the volume of gas in first state or initial state. Now V2, because it is less, so change in volume will be V2 minus V1, or the difference in volume is V2 minus V1. We will get negative. Why negative? Because this second volume or final volume is less. So V2 minus V1 is generally given as delta V. So it will be negative, and multiplied by pressure will give you minus. So this is the work done on the system. When work is done on the system, volume get decreases. Our final state volume will be less than the volume in initial state. The same process can be reversed. The above process can be reversed. How it will be reversed? Like this. We have a cylinder in which gas is filled, and the cylinder is fitted with a movable piston. This was initial volume before we heat it. Now, when we heat it, what happens? The molecules of the gas will gain energy and their kinetic energy will increase. As a result, they will move up and down with the more velocity or faster. As a result, there will be more collisions with the walls of the container as well as on the surface of the piston. As a result, piston will move up. As a result, volume of the gas in first state or in initial state will be more than the, less than the volume of gas in final state or second state. So here V2 will be greater than V1. So the change in volume will be positive and P delta V will be positive. Now, how will we get that equation? Let us consider a system in which a gas is taken in a cylinder fitted with a movable piston as we have shown here or in the above figure. That is, this is the piston, movable piston fitted in the cylinder. And let the P external is the external pressure applied on the gas. When we exert or we place some force or weight on the piston, it will move down due to increase in external pressure, which is force per unit area. So force per unit area is called P external, or force is equal to P external into area. Now the piston will move up to certain distance L. So P external into A into L will be work. And A into L means area into side. Again will give you volume. With this, we reach to this equation, or we get the equation called as W is equal to P into V, or work is equal to P external into volume. And this volume is change in volume from first state to second state or from initial to final state. If V1 and V2 are the volumes of gas, if it is a gaseous system, then in initial and final state, the volumes will be V1 and V2. Then V2 minus V1 will be given as delta V, and work done will be P external into change in volume, that is V2 minus V1, or it will be P external into delta V. If we remove this external, because generally when we exert pressure, that is apply external pressure, compression takes place. Sometimes we remove or decrease the pressure, exert pressure, then expansion will take place. Therefore, we get the final equation as W is equal to P delta V, or work done is equal to pressure, external pressure into change in volume. Now there will be two different situations or cases. Case number one, our first situation is expansion of gas. The second will be compression of the gas. For expansion of the gas, V1, that is volume of gas in initial state, will be less than the volume of gas in its final state or second state. Why? Because the gas is expanding, so V2 will be greater than V1. That is why we have written V2 is greater than V1, and the difference in volumes will be greater than 0, or it will be positive. Why it is taken as positive? Because final volume is more or greater than initial volume, so it will be positive. But the work done is always assigned a negative sign. So work done on the gas is always, work done by the gas is always taken negative. Second case is of compression. For compression of a gas, the initial volume will be more than final volume, or V2 will be less than V1, or their difference will be less than 0, or delta V is less than 0 means negative. But the work here is done on the gas or gaseous system, or the system, it is taken as positive. So you have to remember that the work done on the system is positive and work done by the system is negative. Here you have to remember these two things. Now, one more thing we have to remember always is, for free expansion of a gas, what is the meaning of free expansion? When it is experiencing no external pressure, that means it is expanded in vacuum, or when the gas is allowed to expand in vacuum, external pressure will be zero because there will be no external pressure. So we have to take it as zero, and at the end, because P external is zero, the product of P delta V will be zero, means no work is done by the gas. So this is very important thing. For free expansion of a gas, or when a gas is allowed to expand in vacuum, external pressure will be zero. As a result, the work done in this case of free expansion of gas is zero. Why it is zero? Because the work is product of pressure, external pressure and change in volume. And change in volume is there, but external pressure is zero, therefore the product is zero. The units of work in CGS system, it is erg. In SI system, it is joules. And 1 joule is 10 to the power 7 ergs, or it is also equal to 0.239 calories. And 1 erg is equal to 10 to the power minus 7 joule. We have to note down the work done by a system is maximum work if the process is carried under reversible conditions, that is, no other process will give greater amount of work than the reversible isothermal expansion. As I told you earlier also, the work done in the reversible process will be maximum. So when we take the process of expansion and compression, expansion will give you more work if it is reversible. Therefore, we get the greater amount of work when it is isothermally expanded. So we should remember that. Let us take one example. A gas expands against a constant pressure of 3 atm, that is atmospheric pressure, from 5 liters to 22 liters. We know that the equation to calculate the work done is P external into change in volume. What is change in volume? It is nothing but V2 minus V1, that is final volume minus initial volume. Final volume here it is 22 liters, and initial volume it is 5 liters. 22 minus 5 is 17, and it should be multiplied with P external, that is given as 3 atm. So 17 into 3, that is 51 liters atmosphere, is the work done by the gas during the expansion. Now, another example, calculate the amount of work done when 1 mole of an ideal gas present in a bulb of 5 liters at 1 atmosphere is allowed to enter into a vacuated bulb of 50 liter capacity. How to solve it? You should remember that this gas is expanding in vacuum. Why? Because the second bulb is evacuated, means there is vacuum. So whenever it is vacuum created or originally present, the external pressure will be zero, and you should remember that when external pressure is zero, the product of pressure into volume will be zero. Here, the difference in volume is 50 minus 5 means 45 liters. But since the pressure is P external pressure is zero, therefore work done will be zero. So with this, we will end today's lesson. So please remember these things. We will continue the same things in next lesson or in next part of the thermodynamics or in part 3 of thermodynamics. We will continue the same things. Please remember these things.